How do we get students to apply number sense to help them use the long division standard algorithm? This video will focus on MGSE6 NS2, fluently divide multi-digit numbers using the standard algorithm. In 5th grade, students fluently divide up to 4-digit dividends and 2-digit divisors by using at least one of the following methods: strategies based on place value, the properties of operations, and/or the relationship between multiplication and division. Students illustrate and explain the calculation by using equations or concrete materials such as rectangular arrays and area models. In 6th grade, students fluently divide multi-digit numbers using the standard algorithm. And in 7th grade, students use long division to convert fractions to decimals. These students are using bar models to solve 145 divided by 4. Do you notice how this structure encouraged students to consider the entire amount of 145 and how much of that total amount will be in the 4 parts of it? Take a moment to record some wonders you have about this student's thinking. How might this orientation change the way they think about the computation? How might you use this bridge from what students already know to the new learning? Scaffolding division through strip model diagramming, understanding the standard algorithm, can be found in the 6th grade Unit 1 Georgia Department of Education Mathematics Frameworks. This can be used to walk students over the bridge from using strategies based on place value to understanding and using the standard algorithm. You may have noticed these examples use only single-digit divisors. To obtain mastery on the 6th grade standards, students must be able to divide by multi-digit whole numbers. Take a look at this student explaining how she used partial products to solve 1,236 divided by 20.
61 remainder 16.
Make sure you check with the people in your group to see if they they came up with the same answer as you. If not, make sure you all explain what you did to come up with your answer. Oh, notice, look at there.
What'd you get?
Do you mind if I have Shannon share her way, and maybe that'll help you with your thinking, Jasmine?
Yes.
Okay, go ahead, Shannon. What'd you do?
So what I did was I started with 10 and I got 200 and then minus that got 1036. Then I multiplied 50 times 20 and got 1,000 and then subtracted that and got 36 and then did 1 and that was 20 and then subtracted that and got 16.
It is critical for 6th grade teachers to be able to divide multi-digit numbers using a partial quotient strategy, because if the teacher cannot connect the standard algorithm for division to students' prior knowledge, it may be difficult to learn the standard algorithm. Research has proven that one of the most effective ways to do this is to pose the same problem side by side and work it out in both ways. It is partial quotient, algorithm, and standard algorithm. Watch how this is done with 478 divided by 36. Discuss with your colleagues the similarities and connections between the two strategies. Consider how students' understanding of the partial quotients algorithm can lead to procedural fluency with the standard algorithm. It is important to extend students' number sense by encouraging them to think of 36 and 478 as entire quantities and not individual digits sitting side by side. Possibly using questions such as, how many 36s are in all of 478, may help students consider the magnitude of each number. For students in which this question may pose some confusion, you may ask, how many groups of 36 are in 47 tens? This relies on the place value number sense developed in 2nd and 3rd grade. As you reflect upon the ideas presented within this video, consider developing questions to help students apply their number sense to solve the following problem: 905 divided by 45.